So my dear students, this is going to be a very short and precise session in which I'm going to discuss an amazing topic with all of you. That particular topic, which is basically a struggle for a lot of students. What is that exactly? How to predict the period number and group number from the given electronic configuration or from the given atomic number. This particular topic is from the chapter periodic classification, right? And a lot of students struggle while solving the questions based on how to predict the period number, how to predict the group number, if electronic configuration of the element is given, or if the atomic number of the element is given. And in this particular video, after watching this video till the end, you should be able to solve each and every question based on this particular topic. Okay, so let's get going. Let's get started without wasting any sort of a time. My dear students, first of all, let me tell you how do we predict the period number of an element whose electronic configuration is given. Prediction of period number of an element whose electronic configuration is given. You just need to remember one thing. In the given electronic configuration, whatever is the highest value of principal quantum number, in the given electronic configuration of the element, whatever is the highest value of principal quantum number, that is going to give you the period number of an element, right? For example, let's say these are the electronic configurations of some elements. Look at them carefully. If I ask you, what is the highest value of principal quantum number here? I would say it is 3. I would say period number of the element whose electronic configuration is this, it is going to be 3. What is going to be the period number of this particular element? Look at the highest value of principal quantum number, that's 4. So this element belongs to 4th period. Similarly, the element whose electronic configuration is given, look at the highest value of principal quantum number, that's 5. So this particular element belongs to period number 5. Okay, point number 1. So highest value of principal quantum number, it gives me the period number of an element in the periodic table. Now, my dear students, one exception you'll be remembering over here directly, that is related to palladium. If you look at this particular configuration, right, what do you think should be the period number of this particular element? I would say period number of this particular element should be 4, but in reality, it's not 4, it is 5. So remember it directly. Okay, this was our first point. Looking at the second point, how do we get the group number? How do we get the group number of different elements? There are few rules which you need to take into consideration. My dear students, how do we calculate the group number for S block elements? I believe all of you would be knowing the general outermost configuration of S block elements, that is NS1 to 2. In case of S block elements, group number is always equal to number of electrons in NS subshell, right? Group number is always equal to number of electrons in NS subshell. For example, look at this particular configuration. You have got the element whose configuration is given to us. If you look at this particular configuration, I would say the last electron has entered into the S orbital. So I would say this particular element is first of all the S block element. And in case of S block elements, this is the S block element. Now, if I first of all ask you, what is the period number of this particular element? Highest value of principal quantum number, that's 4. Its period number is 4. If I ask you, what is going to be the group number of this particular element? Group number of the S block element is always equal to number of electrons in NS orbital. This is your NS orbital, which contains 1 electron. So I would say it belongs to your group 1 of the periodic table. Okay. Look at this particular configuration. Again, if you look carefully, the last electron has entered into the S orbital. So it is again which element? It is again the S block element. It is again the S block element. Now, if I ask you what is the period number over here, you know, period number is nothing but the highest value of principal quantum number, that's 5. So it belongs to 5th period. In the similar way, if I ask you what is the group number of the element over here, group number, since it is the S block element, for S block elements, group number is basically the number of electrons in NS orbital. So in NS orbital, how many electrons do you see? 2 electrons. So it belongs to 2nd group. I believe this is clear. Similarly, in case of P block elements, well, this is the general outermost configuration of P block elements, NS2, NP1 to 6. How do you get the group number of the P block element? Pretty much simple. One simple formula. 10 plus sum of NS and NP electrons. 10 plus sum of NS and NP electrons. For example, this is the electronic configuration that's given to me for some element. First of all, if you see The last electron has entered into the p orbital, so it belongs to the p block elements. It belongs to p block, right? If I ask you what is the period number, first of all, the highest value of principal quantum number, that's 4. So its period number is 4. If I ask you what is the group number of this element, group number is going to be equal to 10 plus sum of ns and np. This is your np, this is ns. np is containing 2 electrons, ns is containing 2 electrons. So 2 plus 2 makes it 4. So 10 plus 4 makes it 14. So this particular element belongs to which group? It belongs to 14th group. Okay. Similarly, my dear students, if you look at this particular configuration, again the last electron has entered into the p subshell, right? So it is basically the p block element. If it is the p block element, tell me what is the period number. Period number is the highest value of principal quantum number, that is 3. If I ask you what is the group number is simply going to be equal to 10 plus sum of ns and np electrons. So 2 plus 5 makes it 7. So 10 plus 7 makes it 17. So I would say this particular element whose configuration is given to us, it belongs to the 17th group. I believe this is clear. Let's move on to a few more. This was for p block. Now for d and f block elements. How do we get the group number for the d and f block elements? My dear students, if you look carefully, this is the general outermost configuration of the d block elements, right? In which the last electron enters into n-1 d subshell, right? How do you get the group number? Group number is going to be equal simply sum of n-1d and ns electrons. Sum of n-1d and ns electrons. For example, have a look. For example, this is the electronic configuration that's given to me. If you look carefully, this is your ns, this is your n-1d. See, this is 4, this is 3. That means if this is n, automatically this becomes n-1. So the last electron has entered into what? Last electron has entered into n-1d. If you look carefully, this s orbital, it's completely filled, 2 electrons. That means the last electron has entered into the d subshell. So it is basically the d block element, first of all. It is the d block element. Now, if I ask you what is the period number is very much simple. That is the highest value of principal quantum number, that's 4. If I ask you what is the group number is nothing but n-1d electrons plus ns electrons. So ns contains 2, n-1d contains 6. So 6 plus 2 makes it 8. So this particular element belongs to the 8th group. Similarly, if you look at this particular configuration, again, copper, you all must be knowing, it is the d block element again, right? So first of all, its period number. Its period number is the highest value of principal quantum number, that's 4. If you talk about its group number is going to be ns electrons, 1, n-1d electrons, that's 10. So 10 plus 1 makes it 11. So this is the group number of this particular element. In case of F block elements, you need not to remember any formula. In case of the F block elements, which have got this as the general electronic configuration, and all your F block elements, they belong to which group? They belong to the 3rd group. All your F block elements, they belong to which group? 3rd group. So whenever you see element whose atomic number is from 58 to 71 or from 90 to 103, remember these are your F block elements. These are your F block elements, and all these F block elements, my dear students, they belong to which group? They belong to the 3rd group of the modern period table. Perfect. These are some of the questions which I've given you, right? These are different electronic configurations which I've given you, and I want you guys to predict their period number and group number and let me know the answer in the comment section of this particular video. This is your homework. These are your 4 homework questions, and I would expect the answers of these questions in the comment section. My dear students, this was how to predict the period number and group number from what? From electronic configuration. Now imagine if electronic configuration of element you do not know. Let's say you are given with atomic number. Let's say you are given with atomic number of an element, and from the atomic number of an element, you need to calculate the group number and period number. How do you exactly do that? First of all, these are your noble gases: helium, neon, argon, krypton, xenon, radon, right? Remember their atomic numbers. Atomic number of helium, everyone knows that is 2. Then your magic number, all of you must be knowing, 8, 8, 18, 18, 32, right? What these magic number exactly is all about? See, helium atomic number is 2. Perfect. Now neon atomic number will be 2 plus 8, which makes it 10. 10 plus 8 makes it 18. 18 plus 18 makes it 36. 36 plus 18 makes it 54. 54 plus 32 makes it 86. So these are the atomic numbers of these noble gases, first of all. And you know, helium belongs to first period, neon is second period element, third period, fourth period, fifth period, sixth period, right? Now, moving on to the actual stuff. If atomic number is given and you're supposed to check the period number, you need to remember few things. Number one, if atomic number of an element belongs to this particular category, 58 to 71, if atomic number of an element belongs to this particular category, 58 to 71, then it is the F block element. And in the F block elements, which category it is? These are basically the lanthanides. And all the lanthanides, they belong to which period? They belong to sixth period. Remember it, right? All the lanthanides, they belong to sixth period. For example, you have got the element whose atomic number is 65. 65 belongs to this category. 70 belongs to this particular category. So these atomic numbers, right, they represent the elements which are technically your lanthanides, and their period number must be 6. Period number must be 6. Okay. If you have got the element whose atomic number is from 90 to 103, you have got the element whose atomic number is from 90 to 103. 90 to 103. 90 to 103 is again the block element. Which category? Right now you call them as the actinides, and actinides, they belong to period number 7. Right? So 58 to 71, period number 6. Similarly, your 90 to 103, that is your period number 7. Now guys, for example, let's say you have got the element whose atomic number is 93, right? 93 belongs to this particular category. So the element whose atomic number is 93, it has got the period number 7. Similarly, this particular element whose atomic number is 97, it again belongs to your period number 7. As simple as that. Now, for example, if the element neither belongs to this category nor belongs to this category, if atomic number of the element neither belongs to this category nor belongs to this category, then how do you calculate its period number? Period number of that particular element which neither belongs to this category nor belongs to this category, it is always equal to the period number of next inert gas. What does that mean? For example, you have got the element whose atomic number is 44. 44 neither belongs to this category nor belongs to this category, right? So what do we do? You have got the element whose atomic number is 44. 44 neither belongs to this nor belongs to this. Then I would say period number of this particular element has to be equal to period number of next inert gas. Which is the next inert gas after 44? Which is the next inert gas after 44? This is your next inert gas here. Okay, and this inert gas has got the period number 5. So I would say this particular element also would be having the period number 5. For example, if atomic number is equal to 32, 32 neither belongs to this category nor this category. 32. Now check the next inert gas after 32. After 32, this is the next inert gas, krypton. Its period number is 4. So I would say period number of this particular element is also 4. So this is how you are going to predict the period number of the element whose atomic number is given to us, right? Now, my dear students, one last thing, that is identification of the group. If the atomic number of the element is given and you are supposed to check to what group it belongs to, Again, 3 things, very simple and basic, you are supposed to remember. What are those things? If atomic number belongs to 58 to 71 or 90 to 103, okay, 90 to 103, then it's basically your F block elements. Lanthanides, actinides. And your lanthanides, actinides, your F block elements, they belong to which group? They belongs to group 3, or in the Mendeleev's period table, you call it as third B. Okay, perfect. This is point number 1. For example, element whose atomic number is 63. 63 belongs to this particular category. 96 belongs to this particular category. So I would say these are your F block elements and they directly belong to which group? They belong to third group of the period table. Perfect. Similarly, if Z belongs to 104 to 118, if atomic number of the element belongs to this particular category, then group number is equal to the last 2 digits. For example, let's say you have got the element whose atomic number is 107. Perfect. Whose atomic number is 107. 107, my dear students. 107 does not come into this particular category. Neither this nor this. So what do? I would say group number over here has to be equal to the last 2 digits, which is 7. For example, you have got the atomic number, let's say 117. You have got the element which has got the atomic number 117. 117 neither belongs to this nor belongs to this. So I would say its group number has to be equal to 17, the last two digits. Okay, the last two digits. Perfect. Similarly, my dear students, similarly, one more case, one last case I would say. If atomic number of the element does not belong to this category, or does not belong to this category, or does not belong to this category, then how do you calculate group number? Then group number is going to be equal to 18 minus atomic number of next inert gas minus atomic number. What does that mean? For example, you have got the element whose atomic number is 44. You have got the element whose atomic number is 44. 44 does not belong to this category. 44 does not belong to this category. Now, 44 does not belong to this category as well. So I'm bound to use this particular formula. So I would say group number has to be equal. It's going to be 18 minus. What is the next inert gas after 44? What is the next inert gas after 44? That's 54. After 44, the next inert gas is 54, right? So I'll be writing 54 minus. What is the atomic number Z here? That is 44. So the value comes out to be 18 minus 10. That comes out to be 8. So this particular element, it belongs to group number 8. Okay. One more thing which I would want you guys to remember here. If by using this formula, the answer comes out to be negative. If by using this formula, then the answer comes out to be negative, then you are going to modify this formula. And how the modified formula looks like, it's going to be group number is equal to, instead of 18, you'll be writing 32 minus next inert gas minus the atomic number. This is the formula which you are supposed to use if the value comes out to be negative from this